Inclined planes. Today's episode, we are going to tackle about forces in an inclined plane.
In physics, a tilted surface is also called an inclined plane. Objects are known to accelerate down inclined planes because of an unbalanced force. There are at least two forces acting upon any object that is positioned on an inclined plane. First is the force of gravity, and the second is a normal force. Such an object will experience a downward acceleration of 9.8 meters per second squared. Whether the object is falling downward or rising upward towards its peak, if it is under the sole influence of gravity, then its acceleration value is 9.8 meters per second squared. The force of gravity is also known as a weight. The weight acts in a downward direction, yet the normal force acts in a direction perpendicular to the surface. Let us say in a horizontal surface there is a box, and this box is at rest, it is not moving. What forces are acting on the box? First, there is what we call a weight force or the force of gravity. The force of gravity accelerates the box downward. Then the second force that is acting on the box is a normal force. The force of gravity and the normal force are always perpendicular to the ground. And so in this situation, there are only two forces acting or present. Since the box is at rest on a horizontal ground, then the net force is zero since both forces are at equilibrium or is equal. Then, the weight force of the box is equal to the normal force. Let us say that we have a 32-degree inclined plane or ramp and a box that is put begins to slide down. What are the forces present in this situation now? We still have, first, the normal force, and next is the weight force. Always remember that the normal force always acts in a direction perpendicular to the surface. First, let us break the weight force into two components. We'll name this first as mg cosine theta, and this one mg sine theta. Let us put theta in the angle that it makes. In this situation, the normal force is equal to the component of the weight force, which is mg cosine theta. Suppose that the box was 15 kilograms in mass. It has rested on a 32-degree inclined plane and began to slide down. Find the acceleration if no friction is present. Let us denote the formula of normal force as Fn equal to mg cosine theta, or normal force equal to mass times gravity times cosine theta. The formula for weight force is Fg equal to mg sine theta, or weight force equal to mass times gravity times sine theta. For this problem, let us define a normal force direction as y and a weight force as x. The sum of all forces in the x-axis is only Fg, since there is only one force acting. And the net force is max equal to mg sine theta, or mass times acceleration of the x-axis equal to mass times gravity times sine theta. We don't need the mass in this situation, so we can cancel them out. Then we plug in the values that were given into the formula, which is gravity is 9.8 meters per second squared times sine 32, and the acceleration is 5.2 meters per second squared.